AI in digital twins, beginner level, introduction. AI in digital twins refers to using artificial intelligence to create and manage virtual replicas of real-world objects, systems, or processes. A digital twin is a digital copy of something physical, such as machines, buildings, factories, vehicles, supply chains. AI enhances digital twins by enabling them to analyze real-time data, predict future behavior, optimize performance, automate decisions. Examples include smart factories, predictive maintenance systems, smart cities, healthcare monitoring systems, autonomous supply chains. What is a digital twin? A digital twin is a virtual model that represents a real-world object or system. In simple words, digital twin equals a digital copy of a real thing. What is AI in digital twins? AI in digital twins means using AI to make digital twins intelligent and predictive. In simple words, AI digital twin equals a smart virtual model that learns, predicts, and optimizes real-world systems. Why AI in digital twins is important. Traditional systems are reactive, respond after problems occur, manual, limited in prediction. AI-powered digital twins are predictive, automated, real-time, self-optimizing. They help by reducing downtime, improving efficiency, detecting problems early, optimizing performance. Key features of AI digital twins. Feature, purpose, real-time monitoring, track system status, predictive analytics, forecast future behavior, simulation, test scenarios virtually, optimization, improve system performance, automation, enable automatic actions. Example, digital twin data equals machine temp 85, vibration high, status running, efficiency 75. Simple monitoring example, temp equals 85. If temp greater than 80, print warning overheating detected. How AI and digital twins works. Step 1. Create digital model. A virtual model of the real system is created. Example, machine status equals running. Print, digital twin created. Step 2. Collect real-time data. Data comes from sensors, IoT devices, systems. Example, temperature equals 75, vibration equals normal. Step 3. Analyze data using AI. AI analyzes patterns. Example, if vibration equals high, print possible issue detected. Step 4. Predict future behavior. AI forecasts problems. Example, if temperature greater than 80, print machine may fail soon. Step 5. Optimize or take action. AI suggests or performs actions. Example, if temperature equals 80, print reduce load or shut down. AI in predictive maintenance, vibration equals high. If vibration equals high, print schedule maintenance. AI in simulation scenario equals high load. If scenario equals high load, print system efficiency may drop. AI in performance optimization efficiency equals 70. If efficiency is less than 80, print optimize system performance. AI in anomaly detection status equals abnormal. If status equals abnormal, print alert, issue detected. AI in automation auto control equals true. If auto control, print adjusting system automatically. Full menu-based AI digital twin system, Python. Def monitor system. Temp equals int input, enter temperature. If temp greater than 80, print overheating detected. Else, print system normal. Def predictive analysis. Vibration equals input. Vibration low high. If vibration equals high, print maintenance required. Def simulation. Load equals input. Load low high. If load equals high, print performance may decrease. Else, print, system stable. Def optimization. Efficiency is int input, efficiency. If efficiency less than 80, print optimized system. Else, print performance good. While true, print N1, monitor system. Print 2, predict issues. Print 3, simulate scenario. Print 4, optimize system. Print 5, exit. Choice equals input. Enter choice. If choice equals 1, monitor system. Elif choice equals 2, predictive analysis. Elif choice equals 3, simulation. Elif choice equals 4, optimization. Elif choice equals 5, break. Else print invalid option. Concepts learned from AI digital twins. Check. Real-time data processing. Check. Simulation systems. Check. Predictive analytics. Check. Automation. Real-life analogy. AI digital twins are like a virtual copy of a machine with intelligence. Watches what the real machine is doing. Predicts problems before they happen. Tests scenarios safely. Suggests improvements. Helps avoid failures. Ways to improve this project. You can enhance this project by adding IoT sensor integration, machine learning prediction models, real-time dashboards, 3D visualization, cloud-based data streaming, digital twin simulation platforms. Common mistakes beginners make. Ignoring real-time data. Oversimplifying system models. Not considering scalability. Ignoring data accuracy. Treating digital twin as static. Where AI digital twins are used. AI digital twins are used in manufacturing, healthcare, smart cities, automotive industry, energy systems, supply chains. Advanced systems include smart factory digital twins, city simulation systems, predictive maintenance platforms, autonomous system models. Simple definition: AI in digital twins. The use of artificial intelligence to create intelligent virtual models of real-world systems. Final summary. AI in digital twins is a powerful modern technology. It helps beginners learn. Simulation, simulation, prediction, automation, optimization. It plays a key role in Industry 4.0 and future smart systems.